You may have already heard that the NASA InSight mission will be touching down on Mars on the 26th of November. But why all the hype for this mission? What makes it different from the Curiosity rover that's already on Mars right now? Well, as it happens, there are a lot of differences. If you are pretty up to date with NASA missions, you may recognize the design of InSight from somewhere. That is because this lander is based off the Phoenix lander design, the NASA mission that landed near the North Pole of Mars in 2008. It's about 1 meter high and 6 meters long. The reason NASA reused the design was to keep R&D costs down, as well as hopefully meaning it has a better chance of successfully landing, seeing as NASA have done it once before. You see, Mars doesn't have the best success rate for space agencies. Roughly half the missions destined to go to Mars either didn't leave the ground or failed once they arrived. So by reusing a design that worked, scientists are hoping for a successful landing on Monday. So how do they expect this spacecraft to land? Firstly, it will enter the atmosphere 125 kilometers up at almost 20,000 kilometers per hour. This entry will obviously generate a lot of heat, roughly 15,000 degrees Celsius, which the heat shield will absorb. Once the lander has slowed down enough, the heat shield will pop off and a supersonic parachute will deploy, further slowing InSight down. Yes, Mars does have an atmosphere, although it is very thin compared to Earth standards. With the speed InSight is traveling though, this parachute still makes a big difference. Although it wouldn't be enough by itself to stop the lander smashing into the planet. Unlike the Mars rovers, which had giant airbags to bounce on landing, this spacecraft is using its own rockets to land. So, InSight's legs will spring into position, ready for landing. Once the parachute has slowed it down enough, that too will pop off, leaving just the lander itself. And it will use its onboard rockets to carefully reach the surface. This whole process will be over the course of about 7 minutes. Upon impact with the surface, the rocket will have kicked up a lot of dust, which is not very good for solar panels. So InSight will wait 16 minutes before deploying its solar array to let the dust settle. This is what it looks like sped up in the testing environment before it launched. On Mars, these panels will generate around 300 to 600 watts under normal conditions. However, of course, dust in atmosphere does affect power generation, like clouds would on Earth, so it can be different every day. Looking around at where they think InSight will land, you'll notice it's really flat. This is on purpose. A flat landing area means a better chance of landing correctly. While this is all going on, 2 CubeSats have been following InSight to Mars, called Marco A and B. Their mission is to relay real-time information back to Earth about whether the landing was successful or not, and if the solar cells have successfully deployed. The Marco mission is a technology demonstration mission, so it doesn't have scientific instruments, but rather it carries different technologies. These satellites are really small, only the size of a briefcase. They are the first time CubeSats have been sent into deep space, and no one was sure how well they would do, but so far they have been totally operational. Marco will listen to UHF frequencies from InSight with the antenna on the bottom of the spacecraft, and will transmit that data back to Earth using this big antenna. The big antenna operates like a satellite dish on Earth, except they designed it to be flat so it can be space efficient. Amazingly, these satellites can only generate 17 watts of power, yet are still able to receive signals from the surface of Mars and transmit millions of kilometers back to Earth. Should they not work though, all is not lost for InSight. It can also communicate with some of the other orbiters already at Mars, like the Mars Reconnaissance Orbiter. The only difference is that the MRO can't relay information back in real time. After performing their mission, the Marco CubeSats will fly by Mars, unable to slow down enough to enter orbit around Mars, and instead they will drift forever around the Sun. The Marco team will continue to communicate with the CubeSats to see how long they will last past this mission. So, assuming everything goes well, what will InSight be doing on Mars? Although based on the same design as the Phoenix lander, its onboard scientific instruments are quite different. InSight's main goals are to look for clues about the formation of Mars and compare it to what we know about Earth, so we can better understand the formation of terrestrial planets generally. The way scientists do this is through a seismometer, an instrument which will be able to detect the vibrations caused by Mars quakes and meteor impacts. You see, vibrations from these events travel through the mantle of the planet. And by detecting these vibrations, that will enable us to know the size of the core, the physical characteristics of the mantle, and the thickness of the crust on Mars. The seismometer on InSight will actually be carefully placed with a robotic arm directly onto the surface, and a windshield will be placed directly over it, as the wind would impact this instrument greatly while it is trying to detect the slightest of vibrations. The other instrument is a highly sensitive thermometer, which will take readings from the surface all the way down to 4.5 meters in the crust by using a little hammer to bury the instrument down. By extrapolating the temperatures as it goes down, scientists can predict where the mantle must start and how hot it must be near the center of the planet. With a combination of the data InSight generates, scientists will better understand how the interior of planets impact the surface environment, as it's not fully understood yet. We can't do this from only Earth, as Earth's interior system has evolved a lot, whereas Mars never really got started. Earth has active plate tectonics and a magnetic field, but Mars does not. By taking measurements of the interior of Mars, it is almost like looking back in time a few billion years on Earth before Earth got kick-started. So fingers crossed everything goes well on Monday. I wish the teams involved with the project the very best of luck, as they have already put in several years worth of work into this project, and it hasn't even landed yet. Let's see what InSight discovers for us.